Hello students, today we are going to discuss the motion in a straight line. Motion in straight line. In this chapter, we are going to discuss about the particles which are in motion in a straight line. This is a straight line and this is a particle. Here it is A and here it is B. It has the total distance is yes. Now a particle in motion has distance, displacement, velocity and acceleration. The particles in motion has 4 terms. Sorry students, it is 5 terms. Now we are going to discuss each term detailedly. First, distance. Distance says that the total length of the path. For suppose it is at point A and it is at point B. The length between this A and B is, for suppose it is 100 meters, and there is a particle at A at one time and at B at another time. That now we want to find the distance travel from A to B by this particle. So we can decide the distance as 100 meters. So distance means the length of the path travel, and it is a scalar quantity. It does not depend on the direction. As we move, for suppose it is at A and it is at B, and if the particle goes from A to B, it is, for suppose it is 100 meters, and then return back for about 20 meters, and then go back about, it is at C, and then go back 15 meters. Now we want to find the distance. So the total distance traveled by this particle is AB distance is equal to AB total this path plus BC and CD is equal to 100 plus 20 plus 15. So it is 135 meters. So as we see here, the distance is independent of the direction, so it is known as a scalar quantity. Scalar quantity. Now we are going to discuss the displacement 2. Displacement. Now we can discuss the definition by an example. As we discussed earlier that a particle is at A and goes to B. Now the displacement between those two is that is 100 meters. So we can say that the change in position of the object is called displacement. The change in position of the object is called displacement. Now we want to determine either it is direction dependent or direction independent. Let's see here. Now it is at A and then it is goes to B at B and it goes to D at another 20 meters. Now as we know here that the change in position, so it is at A and it is 100 minus, because it is the change in position as well as direction, because it is direction dependent and it is a vector quantity. So we want to subtract this. It is 80 meters. Now it goes to 15 meters forward plus 15. It is equal to 80 plus 15 is equal to 95. So as we seen here, from this we can conclude that it is direction dependent, and vector quantity. So they both have the same SI unit as meter. The SI unit is meter. Now we want to find what the term gives if we divide by time on both terms. Now we will discuss now as we discuss now distance and displacement, and in this, and distance means the length of the path traveled by the particle. As seen here, it is 100 meters, and displacement, the change in position, it is also same because there is no change in direction. Now we want to find out is displacement and distance is direction dependent or not. Now as you seen here, A, B, C and D. Now we said the length of the path, the total length traveled by the particle. Here displacement, a change in position of the object. Now it is the particle started at A and goes to B and then changes its direction and goes to D for about 20 meters. So the change is 100 minus 20 is equal to 80, or we can say it as final position minus initial position. It is the simplest. Final minus initial position. Okay, now we are going to discuss what are the terms come if we divide by distance by time, for distance and displacement. Now we are going to discuss for distance. First, third one. Now we are going to distance upon time. Distance upon time. Now distance upon time. For suppose if we are going we will draw here. Okay, it is A at your home. Now it is at school. Now it is at A and it is at B. Now you start okay, and it is about 100 meters distance between your home and school. Now you started at 8:15 p.m. No, sorry students, it is a.m. Now we want to reach the school, or you can keep it as 3 kilometers. Now the school is starts at 8:30 a.m. So we have 15 minutes time. 15 minutes. Okay? Okay. 15 minutes. Now, what is the distance by time give? The distance by time gives the term speed. How fast you want to go to cover this distance. Now, if we go slowly for about 10 kilometer per hour, it is 0.4 hour. Now 0.25 hour, sorry, it is 0.25. Now if we go by 0.1 kilometer per hour, we can reach lately. Or if we go by 0.4 kilometer per hour, we can reach it quickly. So the average time taken is 0.2 hour. If we travel by the speed is equal to distance by time, as we discussed here, 3 divided by, sorry students, it gives the speed. Now here distance is the scalar quantity, as we have discussed. A scalar by n, it is divided by time. It gives the scalar only. So it is scalar quantity. Okay. Now it is by its SI unit is meter per second. Now we want to find the distance here. Speed is equal to 3 divided by this 1 by 4. So we have to go for 12 kilometer per hour. It is the speed we required to reach 3 kilometers in 15 minutes. The speed is 12. If we go by 10 kilometers per hour, we will reach extra time. So 10 kilometers the time will require more. Or if we go by 24 kilometers per hour, 24 kilometers per hour, we reach it is into 2, we become into 2. So the time will become half of this, because the speed is inversely proportional to the time. Speed is inversely proportional to time. Okay, now now we are going to discuss about average speed and instantaneous speed. There are two types of speeds. One is average and other is instantaneous. Instantaneous. Now average speed refers to what is the average speed we are going. As seen here, the average speed is 12 km per hour. 12. Instantaneous speed means at a particular time instant, what is the speed of the particle, or if you are going in a scooter, if you look at the particular time, the speed will be shown by the speedometer in your vehicles. Now we are going to discuss about velocity. Velocity. It is fourth one. Sorry. Velocity. Velocity is the change in displacement per unit time. Change in displacement upon time taken. Now as we go, it is at point A, it is at point B. Now it is your home, it is your for suppose your father's office. Now you are likely to go to bakery. Okay, yes, here bakery. Your father called you for his office, which is for suppose 3 kilometers, and you go there, and your work is completed, and you wish to go to a bakery, which is 1.5 kilometers to the office. 1.5 kilometers. Now it takes 15 minutes, or it take 1.5 hour. Due to the sorry student, it is take 15 minutes. Okay, it take 15 minutes. Now the change in displacement, the displacement is, now this is the question and we want to solve it here. Now the change in displacement, so it will 3 and 1.5. The change in displacement is 1.5 because the difference of 3 minus 1.5 is gives rise to 1.5 kilometers, and it here it's in minutes, which you want to convert to hour. So 1/4 hour. So it takes 6 kilometers per hour. So we have traveled 6 kilometers per hour velocity. Now as you see that your displacement is a vector quantity, so the velocity is also vector quantity. So vector quantity. And SI unit is meter per second. Now as of speed we have average and instantaneous values. For the velocity we don't have average and instantaneous velocities. For instance, we have average and velocity, but this same method of speed and speed. Now average and instantaneous. As we have discussed, average velocity is the velocity at for the whole trip. What is the average velocity for the particular instant of time? What is the average velocity? Now we are going to discuss distance can't be equal to 0 and displacement can be equal to 0 or not equal to 0. It depends upon the direction change. Not equal to 0. So now average speed is equal to mod of average velocity. Now what gives velocity upon time? Velocity upon time gives acceleration. Acceleration is also vector quantity and it is direction dependent as that of velocity. Now we will try it here. Fifth, acceleration. Acceleration means the change in velocity upon time. Delta or change in velocity upon time. Now the acceleration is vector quantity. Acceleration is vector quantity and acceleration is vector quantity and it is SI unit is meter per second square. Meter per second square. Okay, now we have discussed about velocity and acceleration and values of distance and displacement for the trip, and we have seen that average speed is equal to modulus of average velocity. Now we are going to discuss the kinematical 4 equations. Now kinematical 4 equations. Kinematic equations. Now we have 5 equations. The number 1 is V is equal to U plus AT, and the second one is V square minus U square is equal to 2AS, and the third one is S is equal to UT plus half AT square, and the fourth one is Sn is equal to U plus A by 2 into 2n minus 1. Now the difference between this and this, it gives the displacement for whole time. For first 1 second, it gives the for the instant time for first second. Now we are going to discuss the ratios. Now at first For S1 means for the first second, S2 means for the second second, S3 means for the third second, and so on. It is Sn. Is this one? It equal to, as we seen, Sn is directly proportional to n square here. From here, it can be written as S is directly proportional to t square. For nth second, it is directly proportional to n square. For the first second, it is equal to 1 is 2. For 2 square is 4. For the third second, it is 9 because 3 square is 9, and so on. It is n square. Now we are going to discuss about this. For the first second, for the second second, and for the third second, and so on. Sn is equal to, now as we seen here, Sn is directly proportional to 2n minus 1. Sn is directly proportional to 2n minus 1. Now for the first second, it is 1 is 2. 2 into 2 minus 1, it is 3. For the third second, 2 into 3 minus 1, it is 5, and so on, 2n minus 1. And there is a ratio between Sn upon S, that is equal to 2n minus, because it is the ratio between this term and this term. The ratio will become 2n minus 1 upon n square. Okay. Now V is equal to U plus AT is used if we have given U or A or T. For some cases, U is equal to 0 or U may not be equal to 0. Now it is given, it is applicable when V is given, U is given, acceleration is given, and S is also given. And it is the same applicable here. And here U, if it is applicable for U is given, T is given, A is given. For finding S, we can use this formula. For the first and second, we can use this formula. Now we are going to discuss some cases. First case is if the velocity at x position is, it is x, the velocity is u, and the velocity is v at y particle, at y distance. Now the total distance between this is total distance. Now we want to find the velocity at the midpoint. For example, it is v dash. It is the midpoint, so it is s by 2 and s by 2. Now we are going to apply. Now we have u, s, u and s. Now we are going to apply v square minus u square is equal to 2as. We want to find the midpoint. Now for the first case, v final is v dash square minus u square here is equal to 2 into a into the distance between these two is s by 2. Now between these two, here final velocity is v square and the initial velocity is v1 square, and the distance is s by 2 between these two, a into s by 2. Now we are going to divide these terms and we equate this to find the v dash. Here this both will become cancelled due to the same terms. V dash square minus u square is equal to v square minus v1 square. Now if we get these two on their left hand side, v1 square 2 v dash square is equal to, and we will take these two on the left hand side, u square plus v square. Now we find the final velocity v dash is equal to square root of u square plus v square by 2. Now we got the final velocity v dash is equal at the midpoint as u square plus v square upon 2. Now we have discussed about this term. Now I will going to explain this. At position x the particle velocity is u, at position y the particle velocity is v, and at the midpoint we want to find the velocity E at s by 2 as we have know this formula from the kinematic 4 equations. Now v dash square minus u square is equal to 2a into s by 2. For the second one, v square minus v dash square is equal to 2a into s by 2, and we have divided these two terms and we have taken this, so the midpoint will become this one. Now we are going to discuss the next case. The next case says that a particle starts with some velocity u and goes to rest at final position. It is at u. After traveling half of the distance or some distance or x distance, the velocity will become u by n, and we have to find the how much distance the particle travelled before reaching rest is y. Now we have given u and x. Now we are going to apply the same formula as applied earlier. V square minus u square is equal to 2as. Now v, it is u by n whole square minus u square is equal to 2 into a into x, 2ax, and it is at rest and it is retarding motion. Rest, this u by n, 0 minus u by n whole square is equal to minus 2ay. And next, sorry student, there is a u by n. Now we are going to divide this one, division. sorry, division. 2a will become cancelled. Here u square is common and 1 by n square minus 1 is x upon u square into 1 by n square is equal to x by y. Okay, now it is both become cancelled and now it is 1 minus n square divided by n square. Okay, or it is 1 by n u by n square minus u square. Okay, students, is equal to x by y divided by 1 by n square. Now it will become cancel this and this. So y is equal to x divided by 1 minus n square. So from this we can conclude that the particle travels x upon 1 minus n square distance to come to rest after some time t. Now we are going to discuss the third case. Third case. Now a particle starts from rest and finally goes to rest at some point. The velocity is from initial to some point, it travels alpha distance and the time taken is t1, and from this point to the last position the travel is beta and t2. The distance here from here to here is s1 and from here to here is s2. Total distance is SF is equal to S1 plus S2. T is equal to T1 plus T2. Now, okay, we want to find V max. V max is equal to dash. We want to find the V max. Now V S1 is equal to half alpha T1 square. Now S2 is equal to half beta T2 square. Now T1 okay, V is equal to alpha T1. It is V. Here V is equal to beta T2 for the second. Now T1 is equal to V1 upon alpha and then T2 is equal to V2 upon beta. Now from this we can find the final velocity. T is equal to V by alpha plus V by beta. So it gives rise to, if we common this, V into 1 by alpha into 1 by beta, and T is equal to V into, if we multiply this, it will become alpha beta, and at the numerator it will become alpha plus beta, and we can get the final velocity as V max is equal to, or you can write it here, V max is equal to alpha beta into T upon alpha plus beta. Now we want to find the average displacement or displacement. Displacement is V max into time. So it will become alpha beta T square upon alpha plus beta. It is displacement. So in this case we have discussed about Bmax and displacement. If the particle starts from rest and goes some distance with alpha in time t1 and goes to rest with velocity b with acceleration beta and in time t2, or it is beta. Okay students, now we are going to discuss two more. Okay, now we are going to discuss the two cases. Now it is the fifth case. Okay, fifth case. Now a particle starts from rest. In m time it travels sm distance, and in n time it travels sn distance. This m, it is n. Now we are going to find out the acceleration. This is a is equal to dash. We use Sn is equal to u plus a by 2 in, or it is a by 2 into 2n minus 1. Now for the first Sm is equal to, it starts from rest, so u is equal to 0. So a by 2 into 2 into m plus a by, it is minus. Okay, now Sn is equal to a by 2 into 2n minus a by 2, and minus, we want to difference this. Sm minus Sn is equal to, this whole become cancel, and it will become a into m minus n. So acceleration will become, first one it is Sm minus Sn divided by m minus n. Okay, we will get this acceleration from this condition.